So as you start moving, this forward into an organization, and you mentioned that you get, you got to about 60%, and then you're hoping to get further. I guess what are that efficacy feedback loop? I think there's some lessons to be learned in how you've structured your organization to make sure you have a good feedback loop to make things get better. And I guess what would you recommend for people, and what have you learned from that?
Yeah, that's an interesting point, right? I mean, when I left Cisco to do this, there was kind of like, hey, one theory was, hey, I need a new architecture. I've got to build a real-time pipeline, which is hard for big organizations to do. But the other thing, there was an organizational component to this. What I found is, as we moved data to the cloud, really the Mist customer support became a proxy for our real customers, right?
Mm-hmm.
Because once we had the data in the cloud, we had the same visibility as our customers did into the data. And this is what I'm saying, the customer support model is getting almost turned upside down, right? The days when and it's getting turned upside down in both aspects, right? From businesses to their customer interface, that support model is getting changed. But from the enterprise to the vendor model is getting changed, right?
Right.
The days of having to argue with your vendor about whether you have a hardware software problem, those days are going away. I mean, because at Mist, I see all your hardware or software problems. I know almost ahead of time, if you're having a hardware software problem. So organizationally, what we did here is we basically took the data science team and tied it to the hip of the customer support team. And that's that efficacy loop, right?
Mm-hmm.
So every support ticket that comes into Mist right now, we basically use Marvis to see, Marvis, can you answer this problem, right?
Mm-hmm. Yep.
And these are the hard support tickets. These are like, why is the barcode reader in the distribution center not working?
Right.
Why are the customers in store X having a problem? But that loop there, we've gotten to the point where now Marvis can answer about 60% of all support tickets that come in. When I tell people how that really gets done, it's like, self-driving cars, it's not one algorithm. It depends on different classes of problems. We have different algorithms, to deal with different problems. Mutual information helps us find broken DHCP. And we have this temporal correlation, that helps solve the problem of, hey, if someone misconfigures a router that affects, whether or not a user gets onto the network, those are very hard problems. Like someone touches something over here on the site, this part of the network, and it screws up this side of the network. And you swear that it shouldn't do that, right? That should have nothing to do, but it does.
Right.
That's the type of stuff
Right.
that AI and ML can help find those needle in the haystack problems.
And I know you mentioned that recently, at least the graph database technology and the relationships and things. How does that play into for an organization to kind of figure out, what is possible and what could have happened, I guess?
Yeah.
Right?
Well, this goes back to, the journey for AI. It starts with the data, but the next part of the journey is really building frameworks on which you can apply AI.
Mm-hmm.
So one of the first frameworks we built here is what we called SLE, which really let us apply mutual information, which really let us, whenever a user had a problem with something, it let us to quickly figure out what network feature was most likely cause that problem.
Mm-hmm.
And our famous story there is we had a famous big customer that had a distribution center with some barcode readers. They never could figure out, it was intermittent what they're having. This technique let us get to the question of, hey, it's really a device with a particular OS. We narrowed it down to that feature that was causing that problem. Yep. The graph database is really kind of a event. You think of graph databases being a way to store data and a framework that lets us apply temporal correlation.
Mm-hmm.
So that lets us solve problems like, we had another big retail customer, where we were doing a POC, they're basically said, hey, you guys, your POC is not working, your competitor is working, but yours is not working. It's like, hey, your stuff isn't working, right? What it turned out to be, temporal correlation was able to let us figure out very, very quickly that what had really happened, and someone had reconfigured a router and changed the MTU size so it would not pass these large authentication packets. So it was preventing these devices from authenticating. And they swore up and down that no changes had been made. But after we did the event correlations, yes, this problem is associated with this event. So that's what, the graph database lets you take the data, put it into a format that lets you apply temporal correlation. Does that make sense? That you have frameworks, you have data science.
Is that framework then the thing that allows you to expand because of the, like you just mentioned, the exponential interactions as you get more and more points that can interact with each other, whether it's at the application layer or software layer or any layer of the OSI or within, is that the strategy for dealing with that exponential complexity that comes as you get more and more granular?
That's the framework that lets you basically start ingesting data from more sources, right? Whether it's a DHCP server, a DNS event, or an event coming from a data center, as you start adding more events into this framework, we'd be able to get more answers. So we know, without the WAN interface, I could tell you that the problem is somewhere that side of the AP. But once I start ingesting events from the SD-WAN router, I can now tell you exactly, hey, your problem is due to your problem is on the cellular interface. I can tell you what happened there.